Hello, students. So this online lecture will focus on the chemical reaction stoichiometry. This lecture is derived from the elementary principles of chemical processes, third edition by Felder and Rousseau. I am assuming in this lecture that the student knows about mass balances without chemical reactions. The occurrence of a chemical reaction in a process brings several complications in the material balance procedure described in the previous sections. For mass balances with chemical reaction, the stoichiometric equation of the reaction constrains the relative amounts of reactants and products in the input and output stream. Yung mass balance din sa chemical reaction stoichiometry, hindi lang ito input is equals output at steady state, hindi meron din generation tsaka consumption. To restate that, so at steady state, yung mga chemical reactions, we can balance them by adding two more terms sa usual na mass balance at steady state. So input plus generation is equals to consumption plus output. So pag steady state, ganito yung form ng general mass balance, pero pwede rin naman at dynamic mass balances, magkakaroon tayo ng plus accumulation dito sa dulo. Pero for next time na lang yung dynamic balances. First, define stoichiometry. So define stoichiometry. So stoichiometry is the theory of proportions in which chemical species combine with one another. Itong example natin dito is yung production ng SO3 from SO2 by oxidation. Without balancing, so for example, hindi natin binalance ng chemical equation natin. So burahin natin yung coefficients. Nakikita natin na yung number ng S ay equal, pero yung number ng O2 ay natin ng konting accounting. So yung S sa reactant side is 1 lang. Tapos yung S sa product side, 1 din. So far so good. Pero yung oxygen ay 2 times 2 is equals to 4. And then sa product side, yung O is equals to 3. So this violates yung law of conservation of mass. So since hindi sila equal, this can't happen. Kaya natin binabalance din yung chemical reactions natin or stoichiometric equation para masabi natin na yung mass ng mga reactants natin follows yung law of conservation of mass. So balik natin yung mga chemical equations natin. Pwede tayo makapag-solve ng amount ng product na mapoproduce from the amount of time na finifeed sa isang process by using ratios din. So kung babalikan natin yung mga learnings natin sa mass balance without chemical reaction, we can say na kapag meron tayong mga ratio, say for example, A to B, transformation from A to B, pwede natin magamit yung same principles pero gamit na yung stoichiometric equation. And we will use stoichiometric ratio to convert the amount of product that can be converted from raw material. So sticking with this example, 2 moles of SO3 can be produced from 1 mole of O2 based dito sa ating stoichiometric equation. So again, these are your stoichiometric ratios. So what else? So 2 moles of SO3 can also be produced from 2 moles of SO2. You should always remember na, tawag dito, kapag ginagamit natin yung stoichiometric equation sa pag-derive ng stoichiometric ratios, yung mga units natin ay palaging moles. So very important na tatandaan natin yan. Kasi kapag yung mga mass balances na sinusolve natin are, say for example, liquids, it is possible na yung given sa atin ay naka-mass. So what happens sa mga hindi pa masyadong sanay mag-mass balance with chemical reaction is naiisip nila na yung stoichiometric ratios are also applicable to mass. So hindi pwedeng basta-basta mag-mass balance ng mga reactive species na in terms of mass pa tayo. So say for example, how much oxygen is needed to produce 1,600 kilograms per hour of SO3 report in kilograms per hour O2. Okay, so for our example here, how much oxygen is needed to produce 1,600 kilograms per hour of SO3? So yung game plan natin dito is first to convert moles mass SO3 to moles, and then convert moles SO3 to moles O2, and then convert moles O2 to mass O2. And then we arrive to our answer. So, paano ba to? So, meron tayong yung chemical equation natin, balikan lang natin, 2SO2 plus O2 becomes 2SO3. So, isulat lang natin para hindi natin makalimutan. 2SO2 plus O2 becomes 2SO3. So, i-check lang natin ng mabilis kung tama ba yung chemical reaction natin. So, by that, I mean kung balanced ba. So, sa reactant side, yung number of sulfur natin is 2. Yung O naman is 2 times 2 is equals to 4. And then plus 2 is equals to 6. And then sa product side, S natin is equals to 2. And then O natin is equals to 2 times 3 is equals to 6. So, balance siya. So, we're good. And then, we carry out our calculation. So, meron tayong 1,600 kilograms SO3 per hour times yung molecular weight ng SO3, which is, ilagay lang muna natin as blank for now. Anyway, let's just calculate. So, yung SO3 ay meron 32.1, may sulfur na meron 32.1 grams per mole ng molecular weight, and O, which has 16. So, multiplied by 1 and multiplied by 3, these are, so still 32.1, and this is 48. And this equals to 80.1. So, 80.1 million natin dito in 1 kilomole. So kung mapapansin nyo, since we are converting from kilograms, yung ating molecular weight now have a unit of kilogram per kilomole. So yung standard unit kasi ng molar mass natin or molecular weight is grams per mole. So pwede natin siyang uh, i-upgrade to kilograms, pero dapat yung denominator natin, uh, gawin din natin, lagyan din natin ng prefix na kilo. So, kung meron tayong milligrams, so kung gusto natin i-keep yung same numerical value ng molecular weight, dapat yung denominator niya na mole ay magkaroon din ng milli, which then becomes millimole. So, milligram per millimole or kilograms per kilomole. Ganun lang siya. No? So, next, so na-convert na natin yung mass SO3 to moles SO3. So, kakancelin na natin yung unit na yun. Then, convert moles SO3 to moles O2. So, para gawin natin yun, kailangan natin malaman yung stoichiometric ratio ng SO3 with SO2. So, moles SO3 ay 2, and then moles O2 is 1. So, kapag wala nakalagay din sa chemical stoichiometric reaction natin, walang na number, so it is understood na 1 yung stoichiometric coefficient niya. So now, ilalagay na natin yung O2. So 1 mole, 1 kilomole O2 will be consistent, and then 2 kilomoles ng SO3. So, lagyan natin ng arrow para mas madaling makita. So, ito yan. And this is this one. So ngayon, ang mangyayari, makakancel yung kilomole SO3. Parang pangalagyan, kilomole SO3. Now, we're left with kilomole O2. So, tapos na natin yung dito. Tapusin natin itong dalawang steps na to. So, convert moles SO3 to moles O2. And then, para ma-revert back natin siya into mass O2 from mole O2. So, gagamitin lang ulit natin yung molar mass ng O2. So, O2 is, diba yung O meron siyang 16 na molar mass. So, O2 then has 32 grams per millimolar mass. So, patulad ng ginawa natin sa SO3 kanina, gagamitin din natin yung kilograms per kilomole na unit for O2. So, lagyan lang natin yung kilograms O2 per kilomole O2. So, ngayon, yung kilograms O2 is 32 na dito sa taas. So, that will cancel yung kilomoles O2. And when we're left, grams O2 divided by hours. So, these two. So, ngayon, calculating this results to approximately 320 kilograms per hour. So, ito yung sagot natin dito sa ating first example. So, what we learned in this example is that para magkaroon ka ng 1,600 kilograms na SO3, you will need about 320 kilograms per hour na oxygen gas. So, in our next lecture, we will tackle limiting and excess reactants. See you there.